possibly make it. And remember, we're going to be talking today about ideas and concepts. So if you have math phobia, there's a little bit of math in the lecture to illustrate that I'm really connected with quantum physics and not just making this up as I go along. The handouts in part are inspired by Laura Gottwald. Laura was at our apartment in New York City with Norman. I think the last time that she came, and I was telling her about my desire to begin writing up these things that I've been thinking about for such a long time. And she said, look, just use a lot of illustrations. And so I've done that here. I think it's needed anyway. Very briefly about me, I was born right before the Nazis invaded Poland, right before World War II. And so I came to consciousness in a world at war. And then afterwards, when Life started publishing all these photographs about the atrocities of the Nazis and the Holocaust, I just couldn't imagine how human beings could do such horrible things to each other. And so then that set for me kind of an existential dilemma that has been with me during my whole life. And I was fairly young when I came to the idea that actually our humanity cannot be taken for granted. It represents a very real achievement. And Walter Wing's awareness of this is underscored by the title of his book when he talks about the struggle to become human. And all of us who have engaged in that really know what a struggle it is. And I think over time we understand, if we don't understand at the very beginning, that we're not going to become the kinds of people that we want to become, people of integrity and courage and kindness and love and generosity and forgiveness, without the assistance of God, without the grace of God. So I was originally going to be a physicist. That was my lifelong love. But realizing that my research in physics would probably be funded by the Department of Defense, and I couldn't do that morally. And in the meantime, I had found the church, and so I decided to weigh in with the church. I mourned the giving up of that vocation for a long period of time. And so I became a theologian. For me, theology aims at truth. I think we don't really talk about that as much as we should, but truth, like any, or theology, like any academic discipline, aims at truth. And so that's always been a passion of mine. So part of the truth of theology would certainly involve matching up our understanding of how the universe works, how the universe is wired, with our belief system, the implicit cosmology that is present in the Judeo-Christian tradition, and for me, specifically the Christian tradition. So that's perhaps enough. And then I'm very pleased that at the end of my life, I'm coming back to quantum physics. And the work that I'm doing now has not to do with solving problems in quantum physics as a professional physicist would do, but issues of how is it that we interpret quantum physics. What does it mean? What does it mean for our culture, our civilization? What does it mean for us as biblical scholars and theologians? So that's what I'm going to speak to. There are two core ideas that you might hold in mind to help you sort out everything else that's in my paper, expressed, of course, very briefly. And that is, there's a text from the Fragments of Heraclitus, one of the wonderful pre-Socratic philosophers. And Heraclitus says in one of his fragments, wisdom is one thing. It is to know the thought by which all things are steered through all things. And when he talks about steering, yes, he uses cybernetics, or the root from which we get cybernetics. And when I said thought, the Greek word is logos. So wisdom is one thing, it's to know the logos through which all things are steered through through all things. So conceptually, as we think about nature, we think about the reason, the order that's in nature. It's understood by mathematical patterns. And so we see an incarnate logos in nature, don't we? And then with regard to that transcendental realm, using that kind of philosophic metaphysical language that mathematicians are reluctant to use, but the fact is virtually every professional mathematician does not think that they're making up mathematics as they go. They think they're making discoveries that have everything to do with the nature of reality. And obviously physicists do the same thing, because many of them do their best work with pencil and paper, even today, and are working with equations. And people have learned that the equations are very trustworthy indeed. So when we speak of the logos of nature, I simply use logos. When we speak of things that go beyond nature, and there are definitely things that go beyond nature, I speak of the divine logos, which is God. So that's in a nutshell how it is that one can link quantum physics or our understanding of nature with our theological beliefs and commitments. The other core idea is that of entanglement. And entanglement can be expressed very simply, and probably most of us, especially people who are in communities of faith, feel this and live this. Entanglement states that everything is entangled with everything else. We are all connected, and everything in the universe is connected. Everything in actuality is connected, and also everything that goes beyond actuality in the way that we understand it, mathematical propositions, for example, natural numbers, it goes on and on. All of those things are connected as well. So the idea of the divine logos, or the logos of nature, and the notion of entanglement are absolutely at the core of everything I have to say. And both concepts are obviously at the core of contemporary physics and have always been implicit since the emergence of physics. In a qualified way, when we talk about our first physical synthesis with Isaac Newton. Isaac Newton and those who followed him did not know that there is only one space-time continuum, and that in nature, space and time are different aspects of the same extensive system. And of course, Isaac Newton believed there were instants of time and there were points of space, and they just were two separate realities standing on their own. I'm looking for my glasses, if I can find them, so I can read. So, my other glasses. So, the material is embodied in a way as a story. First of all, I talk about the centrality of cosmology, worldviews. And then I talk about the Newtonian universe, the universe that we have believed is the actual universe, the real universe, in which majority of people in our culture still take as the absolute truth about physical existence. And then I go into the part of quantum physics, which actually involves relativity theory as well as quantum physics. Those are the two pillars upon which contemporary physics is built. And then I give a theological interpretation of Minkowski's space-time diagram and also the Schrodinger equation. And actually, much to my surprise as I was figuring this out, it comes out incredibly orthodox. It really does. I didn't start with that opinion, but when I discovered that the worldview of quantum physics implies what we would believe, even as Trinitarian Christians, I was absolutely astonished and, of course, very pleased. But I did not begin with those thoughts. So turning now to the paper, the place where I begin is the problem with biblical theology. And rather than expounding, it's really easy for me to get off track, so I'm going to try to stick to my text as much as possible. in order to hopefully get through it. One of the authors that I've been reading recently quotes Langdon Gilkey from a paper that he presented or was published in the Journal of Religion the year 1961. And the title of the paper is Cosmology, Ontology, and the Travail of Biblical Language. And here's the situation as Langdon Gilkey describes it. I'm quoting here a rather long passage, but I think it's worthwhile. Contemporary theology does not expect, nor does it speak of wondrous divine events on the surface of natural and historical life. The causal nexus in space and time which the Enlightenment, science, and philosophy introduced into the Western mind is also assumed by modern theologians and scholars, since they participate in the modern world of science both intellectually and existentially. They can scarcely do anything else. Now, this assumption of a causal order among phenomenal events, and therefore of the authority of the scientific interpretation of observable events, makes a great difference. Suddenly, a vast panoply of divine deeds and events recorded in Scripture are no longer regarded as having actually happened. Whatever the Hebrews believed, we believe that the biblical people lived in the same causal continuum of space and time in which we live, and so one in which no divine wonders transpired and no divine voices were heard. And then another major, even greater authority, if possible, in our tradition is Rudolf Bultmann. And of course, everyone's going to be aware of Rudolf Bultmann's essay on faith and mythology. So continuing, other theologians agree that God does not act in the world. For example, Rudolf Bultmann asserts that the historical method includes the presupposition that history is a unity in the sense of a closed continuum of effects in which individual events are connected by the succession of cause and effect. This continuum, furthermore, cannot be rent by the interference of supernatural transcendent powers. And that's quoted by, it's quoted in Existence and Faith, edited by Schubert Ogden. And then the author goes on and also cites John McQuarrie, whom I'm sure many of you are aware of. And in his Principles of Sacred Theology, 1977, he says the same thing. I have a story to interject, but I won't because I won't get through my material like you. So continuing. So what does this mean? What does this mean? It means that the majority of us who are biblical scholars and theologians don't really believe that God does anything. God doesn't act. That was the title of one of my papers in graduate school. I wanted to address that paper, that issue, and I just couldn't come up with anything that made any sense to me in terms of truth or what was believable. So the presupposition of so many people is that God does nothing in the world. Absolutely nothing. This affirmation that God acts, and then the affirmation that God does act, is either meaningless or false according to this point of view. At best, the truths of theology are purely subjective truths. Adopting this point of view as a fundamental tenet of biblical theology makes it difficult to affirm the faith of ancient Israel and the early church. For earlier generations of Christians and scholars clearly believe that God does act within the world. This dilemma illustrates the critical role of that worldviews play in our interpretation of events. So then we turn to cosmology of the worldview, cosmology of the modern world. And part of the background for this is work that I did long ago in cultural anthropology. And one of the things I learned in terms of the larger view is that every culture in the world, thinking here of pre-literate cultures by and large, have two pictures of reality. They have a reality culture, which enables people to go out and hunt and cook food and do all those kinds of practical things that human beings do in the world. And the other world is a value culture. And obviously the value culture is where theological language and personal existence come up. And what we have in our culture now, and have had for a long time, is a disconnect between what we believe is real physically and what we believe as people of faith engaged in the value cultural traditions. So the worldview of the modern world, I was tempted to trace the history, but that would take far too long. Our worldview until the beginning of the 20th century was the worldview of Newtonian physics. And it's the Newtonian concept of reality that dominates the consciousness of members of our culture. So let's look very briefly at what Newtonian cosmology, what Isaac Newton had to say about the way the world is. Now the first point is that for Isaac Newton, he saw no contradiction between the Newtonian physics and belief in God. Isaac Newton says this in his Optics, again a fairly longish quote, but one wonderful quote. All these things being considered, it seems probable to me that God, in the beginning, formed matter in solid, massy, hard, impenetrable, movable particles of such sizes and figures and with such other properties as most conduced to the end for which he formed them. And therefore, that nature may be lasting, the changes of corporeal things are to be placed only in the various separations and new associations and motions of these permanent particles. That was Isaac Newton. People thought about this incredible work that Isaac Newton had done. He kind of like figured out the world. I lived through this in my own education at St. John's College. And when we got to Isaac Newton, it was like, wow, we have really reached solid ground now. We really have a basis for understanding things. And that was the effect that Isaac Newton's work had on his culture. But people continued to think about what Isaac Newton had done, and the philosophers of science suggested that making distinctions between matter, forces, time, spaces, which can be regarded as primary qualities. So they came up with the notion of these things that are real, identified by Newton, are primary qualities. And they're the things that actually exist in reality. And then there are other kinds of qualities that are secondary qualities. And this has to do with how we perceive these material bodies moving about in time and space. And so then secondary qualities would be colors and sounds and smells and so on, sensory perceptions. And then finally, to complete the inventory of our experience, there would be other qualities that would be tertiary qualities, and these are qualities that clearly belong solely to the human mind. And so you can imagine thoughts, feelings, insights, and all the rest of it as well. And so John Locke, the great English epistemologist and philosopher, is the person who's most associated with these distinctions that are just laid out. And then third, the philosophy that actually came to influence our culture had a lot to do with French philosophy, French materialism, is what we call scientific materialism. And that's what's taught in most of the universities and colleges in the world. It's basically what you get in a first course in physics, and then in the final chapters you'll have a chapter on relativity theory and introduction to quantum theory. So what does scientific materialism, which is what our culture has believed about physical reality for a long time, centuries now, consist of. It is the doctrine that affirms that what is real are material particles moving in time and space by forces that act by contact between bodies, or forces of either gravity, electricity, and magnetism that act at a distance. Some of you might think, why did he say electricity and magnetism? Why didn't he say electromagnetic forces? Because for most of this period, electricity and magnetism were regarded as separate forces, and it was Clerk Maxwell who actually united these two forces in his famous Maxwellian equations. And so these were the only forces that were actually known. The nuclear force and the strong force were, the weak force, so-called, and the strong force were not known before the 20th century. So, according to this worldview, reality consists of material particles in space and time. Every event is completely determined by natural laws and previous events. We live in a closed universe. This means then, for us, that freedom, will, consciousness, value, none of these have any kind of intrinsic reality, and they are epiphenomena, floating on the surface of those things that are real. And ultimately, we, however useful they may be, they really are illusions that are generated by the brain. So, the cultural influence of scientific materialism upon European culture, and by extension North America, was very great indeed. And it gave rise to widespread agreement that Democritus of old spoke truly when he said, "A thing merely appears to have color. It merely appears to be sweet or bitter. Only atoms and space have a real existence." And so this belief that is shared so widely in our culture, then it makes it understandably difficult for people to kind of gravitate to the truth of the statement that we're made in God's image, or that people have intrinsic value, or that morality is somehow rooted in the nature of reality. Morality is rooted in reality. So all of these things then became very subjective. And of course, two things happened. One was that there was this incredible secularization of European culture in the 19th century, which still continues with us. And of course, there was a move towards a very great subjectivity, personalistic interpretations of the Bible, for example, in the field of theology and ethics. So now, also in the 19th century, though, in the middle, there are theological developments that occur that are still really very much with us. One is the publication of Friedrich David Strauss's Das Leben Jesu, which is pretty much the foundation of what we do as biblical scholars. And the other book that is not as well known, but is in its own way, in another tradition, equally influential, only to be left behind, is Ludwig Feuerbach's Das Wesen des Christentums. Absolutely a very wonderful book. I have a very high regard for Feuerbach. I regard him as the greatest philosopher of religion in the past 2 centuries. That is how high my estimate of his is. But his work, though, it was branded and articulated as an attack upon the church and as a kind of atheistic interpretation of Christianity, and that's the way in which it's been received, both by the church and also by his most influential student who was mentored by him intellectually, Karl Marx. Karl Marx read this book when it was published, and he became literally a Feuerbachian until he published in, I think the year was 1847, his theses on Feuerbach. And the very first thing he did when he became, quote, unquote, Marxian, he said at the end of his life, "I am not a Marxian." But the very first thing he did is he applied Feuerbach's understanding of religion to the caste system in India. And he was able to show how the caste system, rather than being this super religious, spiritual kind of belief, actually encoded and veiled the caste system that had been ossified and made permanent within Indian culture. A very, very important book. So then we add to that as well a third figure, Friedrich Schleiermacher, and we have das Christliche Glauben, the Christian faith. And you remember, you probably read Schleiermacher, at least I hope you did when you were in seminary. And he has this Christology and understanding of God that is rooted in the absolute dependence of the consciousness of Jesus upon God. In a certain sense, purely subjective. Feuerbach's thought was very much like Schleiermacher's, and he liked to refer to Schleiermacher as the veil maker, which is what Schleiermacher means in German, doesn't it? So, but still, Schleiermacher has been called king of Protestant theology, and there's a tremendous amount of truth to that. So that's where our culture got. Now, we enter into the 19th century, and we see that problems with Newton's worldview, with his cosmology, began to arrive. There's a background story behind this that's incredibly important, and that is the invention of the concept of the physical field. And it's Michael Faraday, a fundamentalist Christian with practically no education whatsoever, got a job in the lab of Sir David Humphreys, and he got interested in electrical phenomena and magnetism. And so he started doing these experiments that we may have done as kids in school. You take the paper, and you put some art filings on it, you put a magnet underneath it, and you said, wow, look at that, what's going on? So he couldn't describe this process or these things mathematically, so he drew pictures. And those pictures then were taken up by Clerk Maxwell, and he said, wow, this is really interesting. I can turn these pictures into equations. And he did, and that's how Maxwell equations were born. Clerk Maxwell was a little different as a physicist from most physicists in that Clerk Maxwell, Faraday thought that these things were fictions that he created because he didn't know math. But Clerk Maxwell said, you know, I think these fields are real. These fields have reality. And so that was then the beginning of a long journey towards quantum mechanics, relativity theory, where we still are engaged. And there have been recent developments that led to astonishing results. I wrote this book, Electricity and Magnetism for Mathematicians. Part of the trick of reading this material is don't be intimidated. Just read for ideas. This book deals with how it is that one can go from Maxwell equations in a perfectly logical progression and come up with the theory of Yang-Mills. And what happens with Yang-Mills is physicists have always thought that the mathematical patterns govern and influence the becoming of physical events, but Yang-Mills has discovered there's a symmetry. There's a reciprocal relationship. The mathematics appears to generate the physical events. The physical events, astonishingly, appear to give you clues to undiscovered mathematics. And so there's this symmetry and between mathematics and physical reality. Again, obviously, this has everything to do with linking our understanding of physics with theology. Because remember, there's one logos by which all things are steered through all things, and that one logos is, as it were, embodied. We would use in our language incarnate. There are other ways of talking about this. Whitehead calls it this ingression. But in any case, though, these eternal objects or these possibilities and patterns are embodied in the physical world, but they also transcend the physical world. So that's where I get my distinction between nature and God. So there's the logos of the world, and there's the divine logos beyond the world of actuality as we know it. So there are some problems. that were left over from Newtonian cosmology. Virtually everybody in the world during the 1890s thought that Newton had discovered everything there was to know about the world. Max Planck, who founded quantum physics as a graduate of Newton, was encouraged not to do his work in physics because there was nothing interesting to be discovered. But he persisted anyway and got his doctorate. And one of the problems that had not yet been solved in physics was that of black body radiation. You remember when it was set around the campfire that you noticed how the embers of the fire will kind of change color. So that's radiation that's produced by the heat. And if you take a big metallic sphere and have a way of making it very, very hot on the inside, make a little tiny pinhole and see what happens as it cools down. It starts glowing and then it sort of like will recede as the energy goes out of it. That's black body radiation. It's called black body because it's in the sphere, which is a black body. And they attempted to discover the law that would predict the frequency, the color in our language, of the radiation. And they came up with two different laws. One was called Wien's law, or Wien's law. And Wien's law had the advantage of working for high frequencies or very high temperatures. It didn't work at all for low temperatures, so something fundamentally flawed about that law. And then they came up with another law called Wien's law, and that one worked for low frequencies, but for high frequencies it went completely off the wall. So what is beyond visible light? Ultraviolet light, right? And so then they called that to say, this is the ultraviolet catastrophe. How can we possibly explain this? So Planck was the person that was doing the research on this. And one night after a dinner party that he had, he's thinking about it, and he said he got really desperate. And he thought of the impossible. He said, well, look, everybody believed that light consisted of waves. But he said, look, suppose they're not completely waves. Suppose they act like little particles. Now, if they acted like little particles, what would happen? And so he went back then to the second of these two laws, and he, instead of putting the wave element in, he presupposed that the light was made up of a huge number of tiny little particles. And he did the math, and he solved the problem. It was like, wow. It was kind of like a fudge, as far as he was concerned, but when he did it, it was absolutely clear that his new equation predicted exactly, precisely, what the experimental results were yielding. So then that was one issue. Einstein is a contemporary, and Einstein is concerned with another issue. Actually, Einstein played an important role in the development of Planck quantum theory, as well as being the founder of relativity theory. In 1905, he wrote the famous paper on special theory of relativity. And what was behind that was a kind of paradox that had occurred. We all know that if you're moving on a boat, let's say 10 miles an hour, you're walking towards the boat at 2 knots, your total speed is going to be 10 plus 2, right? So it's 12. And so you turn around, you go the other way, and now your speed's going to be 8, because 10 minus 2 makes 8. So what about light? Experiments were done to measure the velocity of light, trying to get its absolute value. And so the experiments were done, and the results were bizarre, because no matter what angle and what the physical situation was for the measurement of light, it always came out the same. It's like, this 8 plus 2 or 10 plus 2, not really 12 anymore. What is going on? So it was totally bizarre. So this had to be explained. There was also this other hypothetical kind of matter that they had to create. Namely, if you believe that light is waves, well, You can't have water waves without water. What's the corresponding material then for light? Well, we'll call it ether. Okay, there's ether, underlying ether there. So people would then, of course, would be engaged in a search for the ether. And so then what Einstein was able to show is he came up with the principle of relativity. And the principle of relativity, strangely enough, is misunderstood by most of us. We think that it means everything is relative. No, the principle of relativity means that the universe is constructed in such a way, in a very convenient situation, every single one of us thinks that we are sitting still. And of course, you think about it, no, we're not. The Earth is turning on its axis, the Earth is going around the Sun, and the whole solar system. So there are these different motions all in different directions, and we don't feel anything, that we're just sitting here. And so the principle of relativity then addresses that fact of experience. And it says that for any system, we create kind of like, from where I am to where you are, we create by our bodies and our locations coordinate systems. And so the principle of relativity actually says that the laws of nature are identical in every possible coordinate system of time and space. So, and then having done that, it was very easy for him to prove that E equals mc squared, which flows from that. I did that in my process theology class a couple of weeks ago. Jennifer was there. And it's astonishing how easy you can prove E equals mc squared if you know a little bit of relativity theory and just have a little bit of courage. It's incredibly simple. I was tempted to show you how simple it is, but obviously there's no time to do that. Other issues. Now, with regard to Planck, getting back to Planck, Planck then was able to say and hypothesize that there is a smallest unit of energy. Newton introduces his role by studying the photoelectric effect, and the photoelectric effect also shows that wave to the light is not simply a wave, it acts as a particle with regard to photons bouncing off reflective surfaces. And he's also able to show that when you did the data, you came up with a number that was exactly Planck's constant, which is the number that he figured out as the constant for when he saw that equation having to do with electromagnetic radiation. There are other figures here, I'll just mention them. Paul Dirac, the great English scientist, shows that there are not only electrons, but there are positrons, antiparticles. And so in the 1930s, you'd have Hubble chambers, and you'd get these two lines coming like out of nowhere, in opposite directions. How does this work? So you have particle annihilation, particle production, that's not Einstein's world. And then, of course, also found in the minds of people is that consciousness they saw played a role in the determination of actuality. Photons, are they waves, are they particles? Well, you set up an experiment one way, that's your choice. You want to see waves? Nature answers you. You get waves. You don't necessarily know where you go, but you get waves. You want to, see if light is particles. You set up an experiment for particles. You get particles. I was like, what is it? Is it a wave or is it a particle? So that was discovered. And then the great French physicist by the name of Broglie was able then relatively to show that things that we think are solid particles or solid masses also have waving properties. One of the most telling things, though, has to do with the creation of our model for the atom. It had been discovered that the mass of an atom is in one location in an atom, which we call the nucleus, and so then a solar system idea of the atom emerged. Huge problem with the early model, namely the electrons are conceived as spinning around the nucleus like a planet around the sun, and it doesn't work, not at all. And the reason why is that a spinning electric charge is going to give up energy. So right immediately down into the nucleus, it couldn't last even for a tiny fraction of a second or fraction of a second. So again, disaster. So this was the motivation as scientists were trying to figure out how atoms work and what their structure is. That gave rise then to the earliest name of quantum physics, quantum mechanics, because it really was mechanics. They're trying to figure out the mechanics of the atom. So all of these things then put us in a new world, literally a new world, a new universe. And so that takes us then to our first handout, and the first handout will be Einstein's universe. Different people in the field, I'm not a professional physicist, obviously, I'm a theologian, but different people in physics think, well, yeah, we have these two core theories, which one leads, which one follows. For practical purposes, I think I find Einstein more clear, but maybe that's because when I was a kid, I read this wonderful book called The Universe and Mr. Einstein, and it deals with relativity theory in an incredibly clear way. You could be a 10th grader and understand the mathematics in it. And Einstein himself said, what a wonderful book it's been written. So I've always been partial to relativity theory. So we are looking at, I'm going to overlook Newton's cosmology, and it's probably a good thing in the interest of time. So you can look at this for yourself. What you have here is a list of the things that are real in the Newtonian physics. Laws of motion, basic law of motion is that force, deals with energy, and then I give you two forms of energy there, all very, very basic to physics. But let's move on now to Einstein and his work in Einstein's universe. The implications of this work, as you can see, scientific materialism disappears. It's just gone. Those of us who are walking around, and that's almost all of us, period, are living in a world that, if you had to say, is this the way in which the world is really wired? The answer is no, absolutely not. As kind of an approximation, sure, it's fine. But we don't live in that kind of universe. The universe that we live in is very, very different indeed. It isn't totally deterministic. It's open. It has elements of indeterminism in it. Mind is an element. Consciousness is there somehow. What's all of this stuff mean? Furthermore, the basic unit of reality is no longer thought then to be the material particle. What is the basic unit of actuality? Events. The so-called Big Bang, or the point of creation of the universe, was an event. And encoded in the event was everything. Everything that was then and everything that was going to be in the future as far as these fundamental properties are concerned. And so time and space are there. They're united. The ingredients and material are there. Just everything is there. So the universe consists then of a network of events. And what Max Planck had discovered is he had discovered that there was the smallest quantity of energy, and energy is the basic metric for an event. What the events are, energy is in events. So here we have Einstein's interpretation of his work. And in his work, this is what's called a Minkowski space-time diagram. And on the left-hand side consists of the past. And we all know about the past from our direct experience. It consists of facts or actualities, see things, waves, and so on and so forth. We know that we're heading towards the future. We know something about it, but we don't know everything about it. So it's not completely determined. And so then the future has within it possibilities that have not yet been actualized, but they could be actualized. We all believe the sun's going to set this evening, right? So we really believe that. And so this is an instance, but it hasn't set, has it? No, it hasn't. So this would be an instance of a possibility that's real, but has not been actualized. It will be actualized in the future. And so then what are those lines? These are two cones, actually four-dimensional space-time cones to the left that are barriers or established borders between what we can see and what we can't see, which in practice means what set of events in the past can actually influence the becoming of a particular event, and then when a particular event becomes, it then is an actuality, and it participates in the determination of the future of its environment. And so then an event stands between. It's a becoming is what it is. And it stands between, it has 1 foot in the past, has 1 foot in the future, and this is what's described by the Schrodinger wave equation. Now, how do things then become actually real? The Schrodinger wave equation is going to be a description of a wave that has within it things that are real in our ordinary sense, or more ordinary sense, and things that haven't happened yet. How do you describe those? Imaginary numbers is what's used in quantum physics. And it's the imaginary numbers, which I'll show hopefully in a few minutes, that give rise to the alternatives that are selected in the process of becoming actual. So I use the term decisions here, namely within the event, decisions are made, namely a selection of those possibilities, because not all of the possibilities that are relevant are selected. That's a Whiteheadian term that comes from process philosophy, which is what I do. The technical term in physics is that of reduction. They say the wave equation is somehow reduced. And so then I have here a description of the becoming of a natural event without consciousness. Consciousness has everything to do with our work as theologians and our giving a theological interpretation of quantum mechanics. So then I talked about 1 and 2 already. I have a definition here of actuality, which because of time I will not use. However, though, my definition of actuality came from Ludwig Feuerbach. Ludwig Feuerbach in his writings says that to be real, in my words, actual, is to be in time and space and perceivable by the senses or by an extension of the senses. And if you can't say where or when something is, it raises real questions about whether it's real or whether you know it's real or not. And if you say it cannot be perceived, then that also raises real questions about whether it actually exists.